David Rives, host of Wonders Without Number. In each episode, we talk about breaking discoveries in science, which reveal that our Creator, the God of the Bible, has left a pattern of His fingerprints throughout the universe. Check out our other resources at davidrives.com. Sign up for email updates to have encouraging nuggets sent straight to your inbox. Subscribe to our free monthly magazine and like us on Facebook for daily inspiration and education regarding science and the Bible. Can you preserve soft tissue in dinosaur bones for 68 million years? Learn about shocking discoveries in paleontology and where the evidence leads right now on Wonders Without Number. Welcome to Wonders Without Number. I'm David Rives, and today we want to inform and inspire you regarding the wonders we find all around us. An infinite number of wonders that point us directly to our Creator, the God of the Bible. Now, you're no accident. I want you to know that you are special, that you were created in God's own image, that Jesus Christ was and is that Creator, and that He has a plan for your life. Now, God has given us an amazing world to explore. Sometimes we find examples of preserved animals and plants in the fossil record, and some have looked at those and claimed that the fossils are quite old, that they're examples of extinct species from millions of years ago. But what happens when we find the same plants and animals still living today? Let's take a look right now. Why should you believe in creation and not evolution? I mean, scientifically speaking. Haven't we proven that evolution is a fact? According to evolutionary ideas, organisms have evolved from a common ancestor over millions of years. As environments have changed, organisms have adapted and changed with them. So why do we find so many living creatures that look remarkably similar to creatures we find in the fossil record? You see, fully formed creatures from nearly every family group appear throughout the fossil record without any transitional forms or ancestors. And these creatures look just like their modern counterparts. Dragonflies look just like dragonflies. Crabs look just like crabs. And parrots look just like parrots. Now, if evolution were true, we could expect a few body plans to be so successful that they've managed to thrive for untold millions of years. But we wouldn't expect representatives from nearly every family group to have survived radically changing environments and supposed mass extinctions without changing. Here are two examples of these living fossils. In 1938, off the coast of South Africa, a fisherman hauled a strange-looking fish onto his boat. He didn't think much of it at the time, but scientists who found it later were astounded. You see, this fish was a coelacanth, and it was supposed to be extinct 66 million years ago. But it was alive and well, living deep in the ocean. And years later, another population of coelacanths were found in Indonesia. The fish were even being sold as food in markets. Now, scientists were shocked that this fish was still alive and virtually unchanged from its fossil ancestors. In 1994, a park ranger in Australia noticed a unique tree while visiting a remote part of the country. What he discovered was a Wallamai pine, thought to be extinct for 2 million years. Environmental experts are ecstatic, and it's been stated that this discovery is comparable to finding a small dinosaur still alive. For evolutionists, these finds are rather shocking because they represent supposed millions of years of stasis despite a vastly changing environment. Why hasn't evolution affected them and the thousands of other creatures in the fossil record that look just like the creatures alive today? If we were to interpret this data, we might say that these creatures were formed fully functioning, but many were buried beneath miles of sediment in a vast catastrophe, sometimes bringing extinction or near extinction. But where does that fit in history? Well, the biblical history is perfectly reasonable when you consider that these creatures didn't evolve. They were specially created by God, and many became buried as fossils during the global deluge during the generation of Noah a few thousand years ago. You know, that's just one more scientific reason that you shouldn't believe in millions of years of evolution. It takes a lot of faith. I'm David Rives. Truly, the heavens declare the glory of God. So, if intelligent paleontologists can be surprised with these types of discoveries, then imagine the perplexity of the scientific community if they found preserved tissue still in dinosaur bones. Would it change our view of these fossilized creatures being millions of years old? Let's find out. My guests today are here to address the topic in detail. Dr. Ed Boudreaux is Professor Emeritus of Chemistry and Chemical Physics from the University of New Orleans and is the president of the Rocky Mountain Creation Fellowship in Denver, Colorado. Now, Dr. John Demassa earned his PhD in organic chemistry from the University of Massachusetts and is an industrial chemist holding multiple U.S. and world patents. So if you would, please join with me now as we welcome Dr. Boudreaux and Dr. Demassa. Welcome to the program.
Thank you, David.
Thank you,
Absolutely. David. It's wonderful to have you here. Now, you flew out from Connecticut.
Yes,
you flew out from Denver. You're here with us today in beautiful Tennessee, although it's raining a bit outside. But tell me just a little bit about some of your research and then some of your work together.
Well, we had looked at the possibility of what Schweitzer and her group had proposed as a stabilizing mechanism for these tissues.
Okay.
And it's all based upon a concept called the Fenton reaction. Mm-hmm. And in the Fenton reaction, we have iron, which we need to start with in that reaction. And then we also have, along with that, peroxide.
Okay.
And then we generate from that things such as peroxyl radicals, hydroxyl radicals, and so forth. Now, those radicals are very reactive. Mm-hmm. And the idea they proposed was those would be the components that would stabilize the structure of the materials.
Oh, okay.
But we found out that certainly they're so reactive that there's no way that they could, impart stability to anything, because they would react to form something different.
Wow. Okay, so when it comes to the dinosaur soft tissue discovery, attempts by some to explain how that soft tissue could survive for millions of years, you've published a paper in the Creation Research Society Quarterly, this special iDino project, which was a detailed report on these findings, including findings in a T-Rex femur bone, including findings in a Triceratops horn, and you published a paper looking at the preservation and degradation of these soft tissues. That's what we want to cover today, and we want to hopefully break this down, a very complex topic, and break it down so that we can all grasp it. Let's hit the ground running and see where it leads.
This is maybe one of the most exciting discoveries, I would say. I mean, it's difficult to kind of put it into some focus or some comparative focus anyway. But this business of the discovery of the soft tissue, of course we'll get into it, sets against some of the historic views, I would say, paradigm of evolution. But we'll see how that is in a moment.
Okay.
So we really open with a question concerning the case of 68 million-year-old soft tissue, really asking, is it 68 million years old? We'll look at that. So what we'll do is provide the background of how we got to this point. We'll look at some of the fundamental evidence, and then the controversy. I have to say, this isn't just sort of controversial in a way as it maybe a creationist might look at it. Within the community of evolutionists, they're looking at it and they're saying, "Oh my goodness, this is really stirring the pot," and we'll see how that is, and perhaps how it may even be causing a bit of mayhem. But again, we'll look at that.
But it's good because that's what scientific discovery is all about.
Absolutely. I mean, that's very true.
Yeah.
I mean, science isn't afraid to take a tumble with some of the evidence and try to explain it. So
sure.
Yeah. Quite true.
Okay, briefly summarize, how did this start? I mean, we know that throughout the years, for a number of years, they were digging up bits and pieces of things that they believed might be soft tissue. But tell us what brought this into popularity.
Sure. So we turn the clock back to about 2003. Jack Horner and his team from the Museum of the Rockies are in the Hell Creek Formation area. This is Wyoming, North and South Dakota, Montana, and so forth. And they pull out a T-Rex. They discover a T-Rex. So that's really where we begin our little story. Well, what happened was that they removed the dinosaur. Of course, the bones themselves are more a cast of minerals, and they're falling apart. They're friable. The fossil is very fragile. They end up collecting a box of these crumbled bones, bring them back to the laboratory. On the stage steps, Mary Schweitzer, working with Jack Horner. She examines what's they've now nicknamed Brex. They determined that it's these pieces are from a thigh bone, and more particularly the inner lining. They take the material, subject it to mild acid, and out from these materials come the flexible, fibrous clump of tissue. And this is what they see there, and undoubtedly they were startled with the discovery.
Wow.
Under the microscope, it looks like fibrous-filled materials with blood vessel channels.
Whoa, that's
Quite
incredible.
Yeah, quite a discovery. So they're staring at this material in the petri dish, and they're astonished. I mean, that's really what happened. And as they looked at it, they were able to determine that it was an egg-laying female. Apparently. So they could tell quite a bit about the dinosaur. So here's a picture of the soft tissue and the bone from which this was derived.
This is a very, very large femur bone, the thigh bone from a T-Rex.
Yes, it is. And in Scientific American, there's a disclosure about the story leading up to the discovery. Schweitzer reports that they ended up publishing these results. I mean, any scientist would publish these results. They're startling. And papers came out in 2007, 2008, and she said it generated a firestorm of controversy. Firestorm of controversy. This was really the discovery of a lifetime. Now, the question became, and in fact, why is it a firestorm of controversy? But how did soft tissue survive 68 million years? Now here I took a little picture of my milk from the refrigerator. It's got an expiration date on it. Everything degrades.
You should throw that away. That's
that's a good, I will do just that. And but everything degrades, including soft tissue. And that's why this was a controversy.
And you're not talking about just, we're talking about things inside the bone that were not fossilized, real soft tissue. When it was rehydrated, it was even stretchy in some parts.
Correct. And at least some of the accessible video clips that you can get on it, it shows that this stuff is a little bit like a chicken wing. I mean, it's that pliable, and it's so it's quite a startling discovery.
Hi, I'm David Rives, host of Wonders Without Number. Like what you're seeing? You can find so much more on the Creation Superstore. You'll find over 1,000 books, DVDs, and other quality resources on origin science, creation, and Bible history. Whether you're looking for nature documentaries, educational books, homeschool resources, or children's videos, we've got it all, so be sure to head over and check it out. Use this special promo code to receive 10% off your first order.
Now, the controversy. So as it turns out, many scientists looked at these results, and they were as puzzled, amazed as undoubtedly the discoverers. Well, one group writes about this. Dinosaurian soft tissue is interpreted as bacterial biofilms.
So they say surely this is not actual dinosaur soft tissue. This is a bacterial biofilm that is sort of growing on whatever that's, and that's the reason it appears to be stretchy.
Exactly right. Good
so what
summary.
do you say?
Yeah, well, here are his words. They say they represent, this material represents bacterial biofilms like a sugary polysaccharide, but a slime common throughout nature. Biofilms form an organic cast and once dissolved out of the bone mimic real blood vessels and osteocytes, which is what Schweitzer and her group claimed.
Okay.
Yeah.
The solution to this, do we think, I mean, this is sort of a fringe view here because Schweitzer, many other paleontologists are now saying, no, this is not a bacterial biofilm.
Right.
This is legitimate soft tissue.
Well, she went back and did further experimentation
Okay.
to show that you have to remove the concept of biological material.
Aha. Okay.
Yeah.
So this was her response, as Dr. Boudreaux pointed out, but a scientist's response is not a quick response. She ended up using new methods of analysis on Brex, the soft tissue, and it's joined with yet another discovery, a hadrosaur remains. And this is published in 2009. And it ended up in the prestigious Journal of Science. And again, we see the same sort of thing. But there's a special piece of information we're going to really focus in on.
Okay.
Same kind of thing, though. We see microscopic pictures, microscope-related pictures of the tissue. And but as chemists, Dr. Boudreaux and I, we really want to see, well, what are the chemicals? And
Right.
that kind of thing.
Okay, let's dive into it.
So let's take a quick look at that. What material did they find? They found what's known as a polypeptide, more particularly collagen. That's the type of polypeptide that they found. Shown here, it's a sort of a bundled polypeptide material. That's what was identified. Now, the result of that was that of that discovery was that it wasn't bioslime. This is genuine dinosaurian tissue.
Okay.
And so all of a sudden, the controversy sort of faded in the sense that once the bioslime proposal was removed, there really was no room, if you like, for other kinds of things. This was tissue that had survived 68 million years.
But this created an entirely new controversy because now that it was soft tissue, how does that tissue survive?
Right.
Right. And she answers that and realizes that that really is where all of the trajectory of this discovery.
Okay.
For soft tissues and proteins to persist beyond 1 to 3 million years, which was sort of the projected view at that time, we proposed tissue fixation over time involving iron-catalyzed free radical reactions. We'll talk about that. So she proposes a mechanism to explain how the soft tissue survived the alleged 68 million years.
Okay.
So we'll try to take that up here. But the basic idea, and I'll let Dr. Boudreaux answer, but it's the concept of a fixing agent. You have to have something to pickle the soft tissue for a long period of time. This is what she came up with. It's known as Fenton chemistry.
Yeah.
Okay.
This chemical equation here is saying that you have some sort of biological unit that contains iron, such as hemoglobin, myoglobin.
Okay, it's
one of
naturally
those.
found in the
And
blood,
it's
so
found in
maybe,
the blood.
okay.
And then, but hydrogen peroxide can be present in aqueous form, and then that can catalyze a reaction to produce HO, HOO, and then water.
Okay.
Now, the point being that those two units, HO or HOO, are highly reactive. They're called radicals. And the idea was, as I mentioned a little bit before, that they would somehow stabilize the fibers in the structure of this collagen. The problem is, we find out that those species react immediately and produce a new product with amino acids.
So we're going to take that up on the next slide, I believe. So how do these radicals do what they do? And at least here we have a picture showing that collagen molecules are coupled together, bridged together. So the hydroxyl free radicals, you might look at them as the fixing agent. This is the pickling agent, and it couples all of these materials together. And so the loose and penetrable collection of collagen is made toughened and impenetrable by the free radical fixing agent.
Okay.
That's
So
what happened.
That was the proposal.
That's
the proposal is that perhaps could help preserve this.
Correct.
Right.
Okay.
Correct. That's the view. Well, so let's test this out in the laboratory, she reasons, and again, any scientist, good scientist would do
Said
just that.
yes,
She does
let's
it.
do that.
Let's test it with normal bird tissue. Of course, it's believed that birds evolved from dinosaurs, so not a bad choice. She
Okay.
writes on the results of this, and she uses what's known as post-mortem ostrich blood vessels and exposes them to red blood cells, where the fixing agent ultimately is believed to be or derived from, rich in hemoglobin, and this is what she says, that these blood vessels, when exposed to hemoglobin, it stabilizes the blood vessels after 2 years.
After 2 years.
Yeah, that's far cry
Okay.
from 68 million.
Right.
We're going to look at that too, because that, when Dr. Boudreaux and I entered into this cooperative writing the paper, we were just struck, at least in part, by this assertion.
Okay.
So here was, at least before us, and we'll kind of look at these several things, but does this Fenton chemistry really explain the whole thing? What do we make of this 2-year experiment that is allegedly giving us evidence that something could survive 68 million years?
Right.
We brought up something, we haven't heard any response to it, but the chemical marker problem. We'll talk about that. And the absence of carbon-14 dating, and we'll just touch on that as
Okay.
well. So what about that? They took the soft tissue. It was in the laboratory for 2 years. In the
Yes.
laboratory for 2 years.
Okay, so in controlled conditions,
Right.
for 2 years, trying to say, oh, we're accelerating this and extrapolating out what will happen. Can it survive?
Right.
Okay.
And so remember, now we have to pause and think about this for a moment. 68 million years, the bones were allegedly in the ground for 68 million years in an open environment, exposed to ranges of temperature, exposed to differing geologic conditions, exposed to background radiation.
Wow. Yes.
All of this is stressing the soft tissue, and so the question comes up, are we really simulating correctly the conditions?
You would have groundwater
Yep.
coming in
Yeah,
and out. You would have
yeah.
freezing and heat waves and all of this interacting
Sure.
for supposed 68 million years.
Sure.
Okay.
Punishing the soft tissue.
Yes.
Well, then we bring up what's called the chemical marker, or if you like, chemical dipstick problem.
Okay.
How did, polypeptides are loaded with oxygen-sensitive materials.
Yeah.
And these chemicals on the collagen act as a marker of
Right.
sorts. If they're around, we ought to question whether the hydroxyl radicals were doing what they say that it was doing, toughening the polypeptide. Okay, what molecules are we referring to? Shown here are methionine, tyrosine, and histidine. These are all amino acids hooked onto this polypeptide. These are all oxygen sensitive, and they should have reacted with hydroxyl or these oxygen-free radicals.
Okay.
They did not.
At least they did not report
Yes.
any evidence of them being found in their experiment.
The evidence that they reported show sort of a fresh presence of methionine, a fresh presence of histidine, a fresh presence of tyrosine. This is very, ought to have provoked a little more question than it did, but that really wasn't addressed in the paper.
Wow. Okay.
Due to its strong reactivity, one would write about free radicals and so forth with biomolecules. A hydroxyl radical is capable of doing more damage to biological systems than any other reactive organic species.
That's right.
This is all over the literature. In fact, Dr. Boudreaux and I this morning were just talking about yet more papers that are out there showing how free radicals damage and do not, say, toughen.
Okay, so I'm breaking this down very simply.
Yep.
Tell me if I've got this right. The hydroxyl fixing agent, they're calling this a fixing agent, saying that perhaps this is one of the processes that help to preserve the soft tissue.
Correct.
However, if that was present, then it should have reacted with these others that we've just seen in a way that is not reported.
Exactly right.
That's right.
Okay,
And
which
not
is a
stabilizing
major
anything.
problem with this iron preservation theory.
Yeah.
We believe it is.
Yeah.
And so the conclusions are that, first of all, we brought up this 2-year thing being a problem, but also we believe that they've overlooked the oxidation chemical marker issue, which we brought up in our paper. And then Dr. Boudreaux said, hey, John, you know, we forgot, we ought to also mention the carbon-14 testing data is absent. They didn't do any carbon-14 testing on this. Now, this is qualified dinosaurian tissue.
Yes.
It's uniquely positioned to give us an idea on the age of the soft tissue.
Okay.
We haven't seen any published data concerning its age, carbon-14 data anyway.
And this is something that you would expect, that with the gravity of this discovery, even though they assume that all carbon-14 should be gone because they assume that it has been around for 60 so million years, still, soft tissue would be the perfect candidate to have carbon-14 testing done. And as far as we know, not any carbon-14 testing has been done on these samples.
We haven't seen it. And if it's out there, we'd like to see it, but we just haven't seen it. That's
Wow.
So
Okay.
we think the young specimen hypothesis, the idea that this is perhaps not as old as we're being told, we think that this is a viable idea.
Echoes of the Jurassic, Discoveries of Dinosaur Soft Tissue is a brand new documentary detailing this discovery, but also looking at, well, the biblical perspectives. Because, break that down for me in the last moment. If you had 1 minute, what might these discoveries be telling us? If it's not 68 million years old, how were these dinosaur bones so well preserved?
Well, I think the conclusion would have to be it's impossible to invoke 68 million years or whatever.
Okay.
Even 1,000 years.
Yes.
Because we know that these types of components degrade very fast,
Yes.
quickly rather. And therefore, you would have to say it's got to be young.
Okay.
I mean, it can't be any extended age. In fact, the younger the better, because the tissue would be more preserved.
Thank y'all so much for being here.
Thank you.
And we'll have to have you back on a future program
Thank
to
you.
discuss
Thank you,
this
David.
more in
It was
depth.
a pleasure.
Thank you.
Yes, sir. This is pretty amazing. Now reports of all sorts of soft tissue and fossils are popping up, even in secular journals. But if these creatures died a few thousand years ago, casualties of a literal event, then that makes a lot of sense. One important thing to remember is that the flood of Noah's day was God's judgment on the wicked. But as we read in the book of Romans, no one is righteous, not any of us. Yet, just as God's grace was upon Noah and his family, God sent his Son, Jesus Christ, so that we could be saved from our sins and the coming judgment and have part in the Lamb's book of life. Have you reached out to him? We hope that you've been encouraged and educated today, and we want to give you the tools that you need to boldly go forward and share what you've learned. Leave us questions and comments on our Facebook page and give us a call to learn more. I'm David Rives, and until next time, keep looking up. Truly, the heavens declare the glory of God. Hello, I'm David Rives, host of the TV show Creation in the 21st Century on TBN and the Heavens Declare video series. Each week we talk about breaking discoveries in science which reveal that our Creator, the God of the Bible, has left a pattern of His fingerprints throughout the universe. Engage with other like-minded believers through the Creation Club. This website offers thousands of articles written by scores of authors in multiple languages. Sign up to get our free monthly magazine delivered to your door. Want more? Genesis Science Network is our free 24/7 TV network, reaching millions of people around the world on internet, Roku, Fire TV, and mobile devices. Shop over 1,000 books and videos on the Creation Superstore, the world's largest origins-related store. Visit our Wonders of Creation Center and sign up for email updates to have encouraging articles sent straight to your inbox. Like us on Facebook for daily inspiration and education regarding science and the Bible.